Moving on to the Pythagorean theorem, there are several more definitions that you can fill in from the document on the wiki. Keep in mind that the Pythagorean theorem is the equation a squared plus b squared equals c squared. And in this case, it's very important that your triangle be labeled properly. Right triangles always contain one 90-degree angle. The two sides that are adjacent to the 90-degree angle are both called legs. So I have two legs, and the side across from that is called the hypotenuse. In order for the Pythagorean theorem equation or formula to work, A and B are always legs, and C always represents the hypotenuse. We're going to do a couple of problems just to practice using this theorem. Perhaps you've seen it times before in middle school, but always good to review. In this first example, we're just going to do some labeling, remembering that the Pythagorean theorem says a squared plus b squared equals c squared, in which a is a leg, b is another leg, and c is the hypotenuse. In example 3, they're asking me to find the hypotenuse. Always important to remember to look at the question and say, what is it they want me to find? In this example, let A equal 5 and B equal 12. If I know the length of these two legs, I can use the Pythagorean theorem in order to find out the length of the hypotenuse. A is 5, which has to be squared. B is 12, which I will also square, and the sum of those equals c squared. In simplifying, I get 25 plus 144 equals c squared. The sum of 25 and 144 is 169, which equals c squared. How do I find out what c is when I only know c squared? In order to do that, I have to take the square root of both sides of the equation, because the square root of c squared is c, and the square root of 169 is 13. That means the hypotenuse for this right triangle, C, equals 13. Example 4 is a little bit different. This time, we already know the hypotenuse. The hypotenuse is going to be 15. I also know that A, one of the legs, equals 9. This example is asking me to find the leg of a right triangle. So I'm trying to find what is B. I can again use my Pythagorean theorem, a squared plus b squared equals c squared. If I'm looking to solve for B, I can simply plug in what I know and simplify, or I could rearrange the equation. I'm going to choose to plug in what I know. So if A is 9, I now have 9 squared plus b squared. Since I don't yet know the value of b, I'm going to keep that as a variable, and that has to equal 15 squared. This gives me 81 plus b squared equals 225. Subtract 81 from each side, and I get b squared equals 144. Again, to find the square root of a squared term, I take the square root of both sides, and what I will find is that b equals 12. So in this right triangle, b is 12. Moving on to page 9, we're going to talk about the distance formula. The distance formula says that the distance between any 2 points with coordinates x1, y1, and x2, y2 is given by the following formula. D for distance equals the square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared. For example 5, I am given 2 points, P and Q. In this example, I'm going to let x1, y1 be the point -3, 5, and x2, y2 will be the point 4, -6. In order to use the distance formula, I'm going to plug in these values. D will equal the square root of x1 is -3 minus 4 for x2 squared plus y1 is +5 minus a -6 for y2 squared. When I simplify, I will get the square root of -7 squared plus 11 squared. That gives me the square root of 49 plus 121, which equals the square root of 170. If I find the square root of 170, that's going to be approximately 13. 13 squared is actually 169, but it's approximate. Example 6, I'll save for you to do on your own if you choose to do so. Right now, we're going to move on to midpoints. On the coordinate plane, okay, the coordinates of a midpoint of a segment whose endpoints have the coordinates x1, y1, x1, y1, and x2, y2 are x1 plus x2 divided by 2. That gives you your new x-coordinate, and the second coordinate will be y1 plus y2 divided by 2. This will give you the coordinates x and y of the midpoint. On a line, the coordinates of a midpoint of a segment whose endpoints are A, that should be A and B, are A plus B divided by 2. So we have two different methods to find the midpoint. If we're looking for midpoint on a line, we simply take the coordinates of the endpoints, add them together, and divide by 2. We're really finding the average here. However, when we deal with a coordinate plane, each point has two coordinates, an x and a y. To find the midpoint x value, I find the sum of the two x's and divide by 2. And to find the new y value for the midpoint, I find the sum of the y values and divide by 2.